Hey guys, and welcome to your next video on systems. These notes are about systems of inequalities, and our learning targets are: I can solve a system of inequalities by graphing, and I can solve a system of inequalities using graphing technology. Let's go. So just a reminder that a system is a set of equations or inequalities that we graph in the same coordinate plane. And when we're graphing a system, we're interested in finding the solution. And the solution is the intersection of the graphs. So in this example 3, I know, why didn't I start with 1? Don't ask, it's a long story. Anyway, example 3. What is the solution to the system of inequalities? The first thing we need to do here is take these two inequalities that are given and write them in slope-intercept form. Now, notice the second one is already in slope-intercept form, but this first one, I need to take a moment and solve it for y. So I'm going to begin by subtracting 2x from both sides. That cancels 2x, bring down negative y is greater than or equal to negative 2x minus 3. Then I need to get the y all alone, so I consider the fact that this has a negative 1 for the coefficient. So I'm going to divide by negative 1 on both sides of the inequality. Y, then negative 2 divided by negative 1 is positive 2. Negative 3 divided by negative 1 is positive 3. But when I divide by a negative, I want to flip the inequality to be a less than or equal to. If you divide by a negative, you have to flip the inequality symbol. So now I have this inequality in slope-intercept form. I should be ready to graph. So this is the first one. I'm going to graph it in red. The y-intercept is 3. Plot a point. The slope is 2. So I'm going to rise 2, run 1. And I'm just going to fill up the entire graph following that pattern with a slope of 2, where I'm rising 2, running 1. Okay, so I've got both inequalities in slope-intercept form. That was step 1. Step 2, graph the lines. Consider if these are going to be dotted or solid lines. So this particular line is going to be solid because if I look at my symbol, it's a less than or equal to symbol, and when it has the or equal to, I connect with a solid line. If it did not have the or equal to, this would be a dotted line. Okay, then step 3, I have to use a test point and shade the inequalities. Well, I like to use the origin 0, 0 as my test point if at all possible. So I'm just going to say, if I were to substitute in a 0 for y and also 0 for x, would I get a true statement here? Well, 2 times 0 is 0. 0 plus 3 is 3. Is 0 less than or equal to 3? And I would say yes, it is. That's true. That's supposed to be a check mark. 0 is less than or equal to 3, which tells me that this portion of the graph that contains the origin is part of the solution set. So I shade that portion of the graph. If it was untrue, I would have shaded the other side. So now I'm going to graph the second inequality. So I got to make sure it's in slope-intercept form. It is. The second one is here. Step 2, I'm going to graph the lines and consider if it's a dotted or solid line. I'm going to graph the second one in blue. It has a y-intercept at 1. It has a slope of negative 1/2. So I'm going to rise negative 1 and run 2 to the right. And I'm going to fill up the whole graph following that pattern. So you do the same on your paper, please. This inequality also has the or equal to line under the symbol, which means we're going to connect with a solid line. And if I use my test point, step 3, and to do my shading, I'm going to test to see if my origin 0, 0 is part of the solution of the blue inequality or not part of the solution. So if I substitute 0 for y and 0 for x, I would get 0 is greater than or equal to 0 plus 1, or 0 is greater than or equal to 1. Is 0 greater than or equal to 1? No! 0 is not greater than 1. So that is not true. So that means my shading cannot include the side that contains the origin. This side is not part of the blue inequality solution. I'm going to shade the other side. Now, step 4 of solving a system of inequalities is to find the overlap. So remember, the solution of a system is really the intersection of the two graphs. So the intersection is any point that got shaded by both graphs. So that's going to include this region that I am shading in black. Any point that falls in this region is part of the solution set. So for example, I may want to know if the point 2, 3 is part of the solution. Well, I would go to my graph and say 2 is here, 3 is up here. Is that part of the solution? Yes, 2, 3 is a solution because, yes, it falls in the shaded region. Now, the point 2, negative 3, that was supposed to be a check mark. 2, negative 3, go to 2 on the x, negative 3 on the y, falls here, and that is not part of the intersection of the shaded regions. So I would say the point negative 3, 2, negative 3 is not in the solution set of the inequality. One last thing I want to mention, if we have less than or greater than symbols, we use dashed lines. If we use less than or equal to or greater than or equal to symbols, we use solid lines. So solid or dashed or dotted lines. All right, this example says to solve the system of inequalities on the graphing calculator, and we're just going to draw a sketch of the solution. So, first thing we're going to have to do is put both inequalities into slope-intercept form because the calculator will not do that step. You have to arrange both inequalities to slope-intercept form first. So take a moment and do that. Pause the video. So here are our two inequalities in slope-intercept form, and now I'm going to show you how to graph this on your graphing calculator. So first you should begin by clearing the RAM on your calculator. So we start with a fresh, clean calculator. And since we're going to be graphing inequalities, I want you to notice that when we push the y equals button, all of these symbols here are equal signs. This doesn't give you an option to make an inequality when we're graphing. So if we want to graph an inequality, we have an app on our calculator that is going to help us do that. So if you will push the apps button, it's purple. We're looking for the app that's named Inequalz. Inequalz stands for inequalities. If you don't have that app on your calculator, raise your hand now, and I'll have to come around and help you with your calculator. Scroll through the list. Yours might not be number 7. Yours could be a different place in your list. There's all kinds of different apps. But I'm going to choose that app and hit enter. And it says press any key. So I just pick a key and press it. And it takes me to my y equals screen. And now I want you to look. If I highlight the equal sign, it gives me choices for inequality symbols. So how do I change the equal sign to my inequality? Well, for my blue inequality, I need a greater than or equal to symbol. That's this one. So how am I going to choose that? Well, it's right above the graph button. So I'm going to choose alpha graph, and it's going to change that to a greater than or equal to symbol. Right arrow, type in negative x plus 2. Remember, your negative button is on the bottom row. Your x button is beside of alpha, and you're going to type plus 2. Arrow down, and let's highlight the equal sign, and again, this menu pops up. It's an alpha shortcut menu. For the red inequality, we need a less than or equal to symbol. It's right above the zoom button. So to make that a less than or equal to, I'm going to push alpha zoom. It changes it to less than or equal to, right arrow. And we're going to type negative 2x plus 5. Remember, your negative button's on the bottom row. Your x button is beside of alpha. Negative 2x plus 5. Now, if you will push graph, you should see the inequalities come to life on your screen. So these are the inequalities, but I'm really interested in the intersection of these two inequalities because that's the solution set to my system. Do you see where it says shades? That is what we're going to talk about, the shading. You can choose alpha, and either of these two buttons will take you to the shades menu. Alpha, shades. And when we're talking about inequalities with systems of inequalities, we want to find the intersection of the inequalities. So we're interested in the inequality intersection. So I'm going to choose number 1. And now the calculator takes a moment and it graphs the intersection. And this shows the shaded region that is the solution set to the system of inequalities. All the points that fall in this shaded region are part of my solution set. Pause the video and sketch this on your paper, please. So this is what I got for my rough sketch for the solution to this system of inequalities. Right now, all I'm interested in is that you can graph it on your calculator and you can translate the sketch to your paper. In our next example, it says to solve the system of inequalities on the graphing calculator and draw a sketch of the solution. So the good news is these two inequalities are already in slope-intercept form, so we're ready to go straight to the calculator. I've already cleared my RAM here. And since we're graphing inequalities, we're going to run the app. So go to Apps, Inequalz. Press any key to continue, and it takes you here to the y equals screen. And if you highlight on the equal sign, it gives you a choice to change the equal sign to an inequality. Well, the first inequality, if we look at it over here, it is a greater than symbol. Well, greater than is right above trace, so we're going to push alpha trace and right arrow X. Go down to the second one. It is a less than symbol. It is right above the window button, so I'm going to push alpha window, right arrow, and we're going to type in X plus 1. Push graph. Let's take a look at it. Here is one inequality. Here's the second inequality. I think there's an overlap there in the middle of those two lines. It's a little hard to see. So I'm going to zoom in by pushing window, and I'm going to change my Y minimum and Y maximum to -3 to +3. And that's going to just zoom in a little bit on those inequalities. Okay. And then I want to push, I want to take a look at the shades. So let's push alpha shades and go to intersection. Now we can see that there is a shaded region in between those two lines. So we're going to take that and we're going to sketch it on our papers. And I want you to understand that every point that falls in between these two lines is a solution. Now, one thing I want to mention, these two lines, or inequality lines, are parallel to each other. We learned that in a system of equations, if we have parallel lines, there's no solution because they don't intersect. Well, the lines don't intersect here, but the shading intersected. So we do have a solution even though they're parallel. All of this shaded region in between them is part of the solution because the intersection of the shading is part of the solution. So let's sketch this on our papers.
I'm going to say hi.
So here is my intersection or my graph of my system of inequalities. So all the points that fall in the shaded region of the graph here are part of the solution of the system of inequalities. The lines themselves this time, this line and this line, are not part of the solution because they are dotted lines. So that means those lines are not included in the solution, just the intersection of that shaded region that's between those two lines. So once again, our learning targets are I can solve a system of inequalities by graphing, and I can solve a system of inequalities using graphing technology.